Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
At Casa Loma Elementary, home of the Comets, and we're all here today to do the math! Yeah!
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mary Lou.
And I'm Chuck. Give us a call if you have questions about your math homework, getting ready for a test. Maybe you've got math to make up if you've been absent. Our phone tutors are waiting. They'll be here until 5:30. Call us here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show online at dothemathonline.net, and you can watch us on or check for us on social media. We're on Facebook and Instagram, Twitter, YouTube.
Yep.
What else?
And I'm sure there'll be more next year.
Yeah.
Anyway, we have a lot of things going on this afternoon. We'll be visiting the students out at Casa Loma Elementary School in a little bit. We have a very special guest in studio, but first let's take a look at today's Math in the News. Nothing with food today. I know you're on today and we usually deal with food, something like about that, but do you know the story or one of the stories behind why we use X as the unknown?
No.
No.
All right. So I saw an article on this. So the question was, what does the letter X have to do with, why is that the unknown? Well, the use of X in this way began with the inability of Spanish scholars to translate certain Arabic sounds. The word for unknown thing in Arabic is al-shalan, and it appeared many times in early mathematical works. But since the Spanish scholars had no corresponding sound for sh, they went with the ck sound, which in classical Greek is written with the chi symbol, which looks much like an X. All right? This was later translated into Latin. The chi was replaced with the more common Latin X. Once in Latin, it was then the basis for math books for hundreds of years. Mm-hmm. So that is how the X comes about. So let's go ahead and take a look at a problem right now. So why X? Well, we have 4x minus 9 is equal to 7. We can see that 4 is the coefficient. X is the variable, the unknown, and 9 and 7 are constants. So they're color-coded so you can see what those are right there. So taking a look at an example, 6 times the quantity x minus 2 plus 5x is equal to 43. So in order to solve this problem, we'll distribute the 6 to the x and the negative 2, where we've had numerous students call in with problems like this. Mm-hmm. Then combine like terms. So we can see we have 11x minus 12 is still equal to 43. Add 12 to both sides to get rid of that negative 12. We have 11x is equal to 55. Divide each side by 11. We see that x is equal to 5. Take now the value for x and substitute it back in to the original problem. Substitute 5 for the x, so wherever there was an x, we'll substitute it. Go ahead and multiply it out. Add the end of it right there, and we can see that 43 is equal to 43.
Checking our work.
Right, which is exactly what all students should do.
Yes.
Because I know we let the students know you need to take the extra 10 seconds,
yes,
check it to make sure that you've got it done.
Because everyone makes mistakes, even
everybody
simple
does it.
mistakes,
We even do on the show.
Throw the whole thing off.
Not that we like to a lot, but occasionally there are some mistakes on there.
And another thing I was thinking with the X, because usually way back when they didn't know how to sign their name, didn't they?
You
put
could just
an
make a
X?
mark of.
Yeah, make some kind of, that's where I was kind of thinking with the X there, the unknown.
We don't know who that is. They
I
are
don't know
X.
who that is, but they're X.
636-4357 is the phone number. We do have phone tutors available until 5:30. And a reminder, if you need some math help, you've got today, tomorrow, and then next week. And that is the end of live programming for this year before we go on spring break.
Yes.
So you've got this week and next week. If you do call from outlying areas of Kern County as well as San Luis Obispo County, that phone number is toll free at 1-866-636-6284. As a reminder, if you call from San Luis Obispo County, we do your math problem on air. You will automatically be getting yourself some ice cream. There's the food for today from Doc Bernstein's Ice Cream Lab. So all you have to do is we do your math problem, you automatically win yourself some ice cream. Right now we'll go to the phones from Rosedale. Braden, how are you today? And are you in 7th grade?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay, Braden, go ahead.
On number 5 in my Big Ideas Math workbook, it wants me to measure the angle of the quadrilaterals given below, and then it wants me to include the sum of each angle measured.
Okay, can you give me one, what does one of the pictures that you have to measure looks like?
It's a trapezoid.
It's a trapezoid? Okay. Is a trapezoid, Braden, does it look like this?
Actually, it doesn't say right now.
Well, look back. Are you supposed to go back to a picture
Yes.
that you did?
Yes.
Okay, go back to the one activity, activity 1. Look at your picture. Look at your trapezoid you drew. Does it look similar to this, or is it upside down the other way?
It's right side up.
Okay, so this is correct. All right?
Yes.
Okay, so we have to find out the unknown measures, okay? So what you're saying is that we need to find out what these angle measurements are, yes?
Yes.
Okay, so one, we could measure it with a protractor. Do you have a protractor?
No.
Okay, so let's do some guessing here, all right? So we know that obviously these two angles are going to be congruent, correct?
Yes.
And then these bottom two angles, are those two also going to be congruent?
I believe so.
Yeah. So these two angles, though, looking at those, Braden, do those look like acute or obtuse or right angles? What do those look like?
Those look like acute angles.
Oh, the top two?
Um,
Those kind of look they kind of look obtuse to me because it looks like they're greater than 90 degrees, yes?
I was looking from the bottom up.
Oh, okay, yeah, the bottom, yes, those are acute. So we know that those are going to be less than 90 degrees. So we don't have a protractor, so we're going to have to do some guess and check work here, right?
Yeah.
So do you know the measurement of a quadrilateral? All four angles, what do they have to equal?
360, right?
Right. So we know that this has to equal 360 degrees. Since these are kind of small, right? And we know that these all have to equal. Do you think, okay, we know it's less than 90 degrees, right?
Yes.
So looking at this, we're just going to have to do a guess and check here. Do you think it's maybe half of 90 degrees?
Yeah, two angles?
Yes.
No, probably a little bit more than that.
Okay, then give me a number.
I would say about maybe 65 degrees.
65 degrees? Okay, cool. Let's do 65 degrees. So if this angle is 65 degrees, Braden, what is this angle?
65 degrees.
Okay, 65 degrees. So we know that both of these are 65 degrees. So let's take our 180, okay? Oh, sorry. Let's take our 360. First of all, what's 65 plus 65?
I believe 130.
130. Okay, so let's subtract that from our 360. What do we have left? Do we have 230 left?
Yes.
Okay, so we have 230 left, right?
Yes.
We know that the top two angles are congruent. They're going to be the same. So Braden, what can I do with this 230 to figure out these two angles?
Divide it into two.
Exactly, divide it into 2. So if we divide this into 2, into half, What's half of 230?
112.5.
Is it 112.5? Let's see. Well, we know.
No.
Let's look at that. We know 2 goes into 2 one time. We know 2 goes into 3 how many times? Is that 1 time?
Yeah.
And we know that we have 1 left over. So 2 goes into 10 how many times?
Well, 2 goes into 10, 5 times.
5 times. So what about 115? Yes?
Yeah.
Double check. 115 plus 115, 230?
Yep.
Yeah. So therefore, this must be 115 degrees. And if this is 115 degrees, then this is 115 degrees. And we know, again, by double checking, 65 plus 65 plus 115 plus 115, we know that it has to equal 360 degrees. And there you go, Braden, okay?
Thank
Nicely
you.
done,
welcome.
Braden. If you're still online, congratulations, since you made Mary Lou do a little bit of extra work right there. We're going to send you home with a meal courtesy of our friends at Johnny Rocket, so congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. In studio with us right now, our very special guest, Michael Garrett. How are you?
I'm great. Good to see you.
Nice to see you again. And we have seen each other over the years a couple of times because you are with the San Luis Obispo County Office of Education.
That's right.
And what brings you to Bakersfield today?
Well, I'm working with CCETC, which is an organization that Kern County, as well as San Luis Obispo County, and a number of other counties in the state are members of, where we purchase media that's used in the classrooms, and specifically California Streaming, which is an online distribution system for video content, other media content that's used by a lot of students in your county as well as throughout the state.
Okay, so you guys are all getting together, talking a little bit about that. As far as what you do at your county office, what is your title there?
Yeah, so I'm manager of the Educational Technology Center.
Okay.
So we do a variety of things similar, I think, in part to what you guys do here. We manage a television station, so we do video production, broadcast services. We don't have as nice studios you guys have here, but we do a lot of similar things, as well as our online resources. So California Streaming, we have a web portal that all teachers and students have access to. We administer that and do trainings for that in our county.
And you guys have been partners with Do the Math for a number of years now.
Right.
And that's probably a reason why you don't need necessarily a studio, because you carry Do the Math and support Do the Math, and we love going over to visit your schools each and every year. And how have you seen the show grow? I mean, from your standpoint, because I think we're in our 15th year now, but we've been with you guys only the last couple of years.
Right.
So some things that you've seen with the program over the last few years.
Yeah, well, certainly, I've noticed a lot of the groundswell of participation in social media, the way that your students out there using it have really grabbed on, and having study groups that get together is really powerful, great way to see that the way that they're using the resource. And from the standpoint of the show itself, a lot of the remote content going out to sites, showing the students using it. Obviously, a lot of changes in technology that you guys have been able to incorporate. It's just been really powerful to see the way that you guys are using the resources to bring math into the classrooms.
Yeah, the smart board that we have now, and it wasn't too long ago we had the slate and the chalk, and we don't know that back that far, but we had the whiteboard over there,
right, I remember.
and that was a standard for many years until we had some other supporters come in, and we were able to grab some money and be able to update the technology and things like that. You spoke about the social media, because I know when we go over to the schools and we post those things on Facebook, those families hear about it, and then they get on there and they find out about the program and then kind of spread it out to others from there. How do you incorporate math in what you do at the county office?
Yeah, I'd say there are two main areas. One is in contract development, which is a big part of what we do. We provide services at the county office to all the school districts in our county, including contracting for California Streaming and a variety of other resources that are used by teachers and students in our school districts. So there's a lot of math that goes into developing contracts, figuring out the finances behind the contracts, what we charge our districts, making sure it's reasonable and it covers our costs, as well as budgeting. This is the time of year in counties where we look at our budgets, and we have to make sure our expenses and our revenue match up.
We had a big county administrator on last week, and that was the big thing, budgets and how to make sure everything comes out. Well, you know what? I know that you guys have a lot of things going on today. We certainly do appreciate the cooperation of San Luis Obispo County with Do the Math, and look forward to going to visit some schools again next year.
Sounds good.
All right. We do have phone tutors available until 5:30. Right now, let's head on out to Casa Loma Elementary School with Devin.
Hey, Mike, how's it going? We're
All
here
right,
at
cool.
Casa Loma, and we're joined here by Denise in the 5th grade here at Casa Loma. Denise, how are you starting to count down the days to spring break? Are we getting there? Close enough?
Yes.
Getting close to... Do you have anything planned for spring break at all?
Yes.
What do you have planned for spring break?
To go to Six Flags.
Going to Six Flags. Well, that might be a ways off, but we're here right now. So let's go ahead and take a look at a problem that you have been working on from your homework. Let's go ahead and read. An air freshener used 2.5 milliliters of perfume. If Tiffany wanted to make 3 air fresheners, how many milliliters of perfume would she use? Now, Denise, you started doing this problem, and you recognized pretty quickly that it was a multiplication problem, and you told me that you had a little bit of trouble turning this into an improper fraction. Now, we can go over that, but, you know, that's not the only way we can work through this problem. Let's go ahead and go back to this problem and first ask ourselves, what is the question asking us to find? So what is the question asking us to find?
Find how many milliliters of perfume she would use.
Right, so we're going to find out how many milliliters of perfume she would use. Now, you were able to go back into the problem and recognize that an air freshener is going to use 2.5 milliliters. And what I think that you did very well here is you represented one bottle of perfume for 2.5 milliliters rather. Now, how many of these 2.5s are we going to need for all of the air fresheners in this problem?
3.
So we're going to do one of two things. We can either multiply by 3, or we can add 3 of these together. Which would you like to do?
Add 3 of them together.
Let's do that. So we're going to add 2.5 plus 2.5 plus 2.5. What is something you're thinking about when you see all this, about how you're going to be able to add all these together? Or what do you notice about all of these numbers that would make them easy to combine?
Times them.
So you're thinking of multiplying the parts, right? We can do that, and that's what multiplication is. I have a suggestion, if you don't mind. What if we break each of these 2.5s apart? This is called decomposition. This is where we take a complex value and break it down to just the smaller parts. So instead of thinking of this as 2.5, why don't we think of this as 2 plus 1/2? And we think of this 2.5 as 2 plus 1/2. And we think of this 2.5 as 2 plus 1/2. By breaking these apart, you now have easier pieces to add together and combine. Because what parts of these are easy to put together that are similar? Because if you think about addition, you can move these around and it'll still be the same sum, correct? So which of these can we move together to make them easier to add?
Add them.
Well, what are we going to add?
2s.
Let's add the 2's. So how many 2's do we have? We have 2 plus 2 plus 2. What does that equal?
6.
6. Great. Now what's left for us to add?
3 more 2s.
Are these 2's here?
No.
We have this value, we have this value, we have this value. What are these?
Halves.
This is 1/2. So we're adding 1/2 plus 1/2 plus 1/2. Now to think about it this way, what does 1/2 plus 1/2 equal?
2 halves.
2 halves, or,
2 wholes.
well, is it 2 wholes or 2 halves? If I have a circle half and I have a circle half, how many holes do I have here?
1 whole.
1 hole. So this is 1 hole. And then we have this 1/2 that we still have to add. I have 6 plus 1 plus 1/2. Can we combine any of these by adding?
Yes.
What do we want to add now?
The
Or rather, what's easy to add now? Do you like that 6 plus 1?
6 and the 1.
So that's going to be 7 plus 1/2, or 7 1/2. We can do this without multiplying when we break it down into simpler adding. Denise, wonderful job. Mike, back to you in studio.
All right, thank you for that, Devin. We'll check it back with Casa Loma in just a little bit. We do have phone tutors available until 5:30, but right now we'll go back live to the phones. And a student from Stockdale, Ella, how are you today?
Good.
And you're working on surface area, correct?
Yes.
All right, as soon as you're ready, let's hear the measurements that you have.
Edward Box Makers produces Parkin Watson. Each has a length of 40 centimeters.
So 40 centimeters?
40 centimeters.
Okay.
A width of 25 centimeters. And a height of 19 centimeters.
What was-
So let me get this. 19 was the height, right? This was the width, and the first one was at the width. Was that the length?
The length is 40 centimeters.
Length. Okay. All right. I just want to make sure I got all of these. All right.
Find the minimum area of paper required to wrap each box.
So this is a
Okay,
box.
the width is 0.5 centimeters.
Is that what we had?
The width,
5 centimeters.
5?
25.
25. Okay, so I got 40 centimeters, 25 centimeters, and 19 centimeters? Okay.
Yes.
And this is a box, right?
Yes.
So it's a box like this. Let me just draw it down here, and I'll try to do the work over here. And let's see, the width is 25, the height is 19, and the length is 40. So is something like that? Is that what you have?
Yes.
All right, and they want you to find the surface area of this?
Yes.
And are we talking about all 6 faces? I mean, it's not an open box, is it?
No.
All right, so we've got to find the surface area, and that means we have to find the area of the front and the back, right?
Yeah.
So let me sketch in the back here. And the top and the bottom, right?
Yes.
And the right side and the left side.
Yes.
Now, the nice thing about this box, it's rectangular, is that right? All of the faces are rectangles?
Yes.
So that's nice because we know that the front and the back are the same, aren't we? Don't
Yeah.
we? So let's find that. Let's find the front. All right? And let's find the area of the front of this. So the way I've labeled this, I did 20 across, that's our width, and 19 up, that's our height, and 40 back. So to find the front, we just need, let's see if I can change this, we just need this right here, don't we? Okay? So
Okay.
let's find the area of that rectangle. The area of this is length times width, or in this case, right? In this case, it's the width times the height. So it's going to be 19 times 25, isn't it?
and to save you
Yes.
time, we'll go ahead and just multiply that out. That's 475.
475. But we also have the back, don't we?
Yeah.
So do you have a formula for this, or are they just having you find them individually?
Excuse me?
Do you have a formula for finding the surface area?
Width times height times 2 plus length times width times 2 plus length times height times 2.
All right. So instead of doing this again, so we know we're going to take 2 of those, right? So when we're all done, we'll take 2 of these, won't we? That'll be
Yeah.
the front and the back. So let's take the front twice, right? So let's do we just did the width and the height, didn't we?
Yeah.
Right, so now let's do this side, and if we do the right side here, that looks like it's going to be the length times the height. So it'll be the length times the height. That'll be 40 times 19, won't it?
Yes.
So let's take the side. I'll write this as the side. And that area is going to be, well, if we take 40 times 19, right? So that'll be 19 times 40.
And that will be 760.
760. And then finally, we'll do the top and the bottom, right? So we finally
Yeah.
got to the length times the width. So length times the width, I think that was the first thing that you said. But in this picture, we did the front first. So let's do the top.
Okay.
So that's going to be the length times the width, which, and let's see, this would be the top. So the area is going to be, what, 25 times 40, isn't it?
Yes.
And that will give you 1,000.
1,000. So we just found 3 of those faces. We found the front, the right, and the top, but we know that all of those have an opposite, don't we? The front's got the
Yes.
back, the right's got the left, and the top's got the bottom. So if we want the total surface area, so do you use a symbol for surface area, or do you just write it out? Sometimes they write SA for surface area.
You do times 2.
Okay, so we're going to take our surface area. I'll just write it out. Surface area is going to equal 2 of the first one, right? 2 times
Yes.
475 plus 2 of the sides. That's going to be 2 times 760, right?
Yes.
Plus 2 of the top and the bottom. That's going to be 2 times 1,000. So
Yeah.
this isn't too bad. What's 2 times 475?
950.
950. That's not too bad because you could go 2 times 400 and 2 times 75. That's going to be 800 plus 150, isn't it? And what's
Yes.
2 times 760?
1,520.
Again, not too bad. You can almost do that in your head, right? Or you can. That's 1,400 plus 120. And whoops, I left the 0. And I'll do the easy one, 2 times 1,000. That's easy. That's 2,000.
Yeah.
So we know that the total surface area, and all we had to do, just like you said, is we had to make sure we took 2 of each of these because there's a pair of them. And so what do we get when we add those up?
When you add them up, it equals 4,470.
4,000, and that's just adding 950, 1,520, and 2,000. That looks pretty good to me. Okay?
And let's put the appropriate.
And let's see, we were
units.
in centimeters, weren't we? So
Yes.
we knew that this was going to be square centimeters all the way down. So our final, I didn't put any of those here, but our final answer is going to be in square centimeters for our total surface area. Great, thanks for the call.
All right, nicely done. Elle, if you're still online with us because that was such a wonderful problem, we're going to send you home with a ticket to Maya Cinemas. So you'll be able to go to the movies and check out something new.
Very cool.
Congratulations on that. We do have phone tutors available until 5. Any new movies you're hoping to see or anything that's out? Or
Well, the Marvel movies, I love all those.
okay. Well, is that the Batman Superman thing?
No, Deadpool.
Not that Deadpool.
Oh,
Well,
Deadpool.
Deadpool, and then also the other one with Iron Man and all that. Isn't that
Oh,
one
okay.
coming out?
There's a new one coming
So
out.
let's take a quick poll here.
Captain America.
This one with Batman and Superman. You know, it's like who's supposed to win?
Wait a
Superman.
minute, they're both good guys.
They're both good guys.
Superman's gotta
if
win.
somebody must win, we can talk about this off air. I don't know if there's a power that Superman is going to lose to Batman. I mean, how?
Kryptonite.
Well, if he has kryptonite,
There you go.
he's going to be able to possibly do something to eliminate it. Anyway,
Yeah.
Emma, how are you this afternoon? Hello, Emma.
I'm on hold.
Oh, no longer. You're on right now. Are you there, Emma?
Yes.
You ready to go?
Yes, sir.
All right. As soon as you're ready, let's hear that math problem.
Okay. I have a question. I don't know if it's a parallelogram or a trapezoid, but the first 3 angles have 65 degrees.
Okay, Emma, let's do some pictures. You said parallelogram or a trapezoid. Here's a trapezoid.
It's kind of like a deformed parallelogram, actually.
A deformed
So it's deformed. There you go.
parallelogram.
Yeah.
So it doesn't look like a trapezoid. No?
No.
Does it look something like this then? Does it look something like that, Emma?
No, ma'am. Well, the top part you have a little correct, but it's kind of it's really hard to explain.
Okay. All right, so let's go ahead. What else is there with the information?
There's 3. It gives me 3 angles, and the degrees for the angles is 65 degrees,
Okay.
109 degrees, and then 106 and 136.
136 degrees. Okay, and then you have to find the fourth angle?
Yes, ma'am.
And is there an X right there, Emma?
Yes, ma'am.
Okay, so what we're doing is, what do we know about quadrilaterals? All four of those angles have to equal what?
360 degrees.
Exactly. So let's write our equation out. We know that 65 plus 136 plus 109 plus x all has to equal 360 degrees, right?
Yes, ma'am.
Okay, so let's go ahead and add these up because we're going to combine our like terms. So we want to add up 109, 136, and 65. Okay? So what's 9 plus 6 plus 5?
9 plus 6 is 15, plus 5 is 20.
There we go. And what is 6 plus 3 plus 2?
6 plus 3, 2, that's 11.
Well, there you go. And then I'm going to do that part. So this all equals 310. So we know that this is 310 plus a number has to equal 360, right?
Yes, ma'am.
So we need to find out this x. So what's the difference between 360 and 310?
Well, there's, if you subtract it, you get 50. So they're 50
Exactly.
apart.
There you go. Guess what your missing angle measurement is?
It's 50.
It's 50 degrees.
50 degrees.
And there you go. And it doesn't matter if we don't know what the shape looks like. As long as we understand it's a quadrilateral and there's 4 sides to it, then we understand that we know that all 4 of those angles together, they need to equal 360. So we could write that out into our equation and just simply solve for the unknown there. All right?
All right, thank you.
Thank you for calling, Emma.
Nicely done right there. Emma's got her name entered into the drawing for the 4 tickets to go see the Bakersfield Condors. We'll be back with more right after this. Some of the students may be looking at this going, all right, we've got the flaps, the aileron, the wing. What do we have on the ends over here?
Okay, all this is what's called static wicks. Okay, as this airplane flies through the air at 400 to 430 knots speed, tremendous amount of static electricity, especially in clouds and in rain and snow. So this airplane builds up a tremendous amount of static electricity, and we got to get rid of it somehow. The airplane is designed to be able to carry that through, and it literally exits the airplane through these static wicks. And then you come around to the wingtip, and what you see here is the lighting system, and we have different colored lights for each wingtip. The left wingtip is red, the right is green, and the back is white. So when I see lights coming at me at nighttime, I know what direction the airplane's traveling in.
Now, as far as lights, I know that we're not on a runway right now, but there are lights on a runway, and are there different colored lights, and why would they be different instead of just white lights?
Yeah, it's the runway lights where you take off and land are white.
Okay.
Taxiway lights where you actually taxi to the runways are blue. Okay, and as you get close to the end of the runway, the lights that are supporting it start turning red. Okay,
Letting you know you're getting close to the end of this.
You're running out of distance, or hopefully you're getting the airplane stopped. Now, this particular airplane is fairly sophisticated, and we have a single point fueling system on the other side of the airplane. So we can take a hose, hook it up to the airplane, and it pumps fuel and feeds all the fuel tanks. But if that system was to fail, or the truck didn't have that capability, we can still come and fill the wings right here over the top of the wing, okay? The 1,000 gallons of fuel is held in both wings entirely. So it's hard to believe, but these wings will hold that volume of fuel. And it actually goes down to the bottom of the airplane, and it's where it pools together, and that's where fuel pumps for the engines and that type of thing, and all the electronics to measure the amount of fuel that's on the airplane. Very important for us to know exactly how much fuel we have.
Right.
It's what's so interesting, you know, and the bigger the airplanes, the more sophisticated, the more fuel they have to carry. Like a 747 actually carries fuel in the horizontal stabilizer of the airplane. And they use it, 2,000 gallons, believe it or not, fits in the horizontal stabilizer of a 747. And they use that fuel to help balance the weight of the airplane as they're burning fuel off.
Now, what's the difference in octane?
between the fuel that you would use in these planes as opposed to
a car?
another vehicle?
Okay. We have two different types of fuel. We'll talk about aviation, but it kind of relates to cars too. Cars use gasoline. Piston airplanes use aviation gasoline. But when it comes to turbine-powered airplanes, jets, all the jets that the airlines fly, this particular airplane, turboprops, they all use Jet A, and that's a kerosene-based fuel.
Okay.
It doesn't have the high octane rating. It's a heavier fuel. It's harder to ignite, but puts out more energy, and it's supposedly cheaper to buy. So anyway, we have this whole airplane ready to go. When the passengers get here, we load the baggage in the back. There's a baggage compartment. They get up in the airplane, they sit down, and we shut the door, start the engines, and we take off. They're in the back talking business and doing whatever they want to do.
About anything else
And
going
they don't
on
worry
up
about
front.
anything else. And then in 2.5 hours, we have them in North Dakota, and they're taking care of business as they go.
Good. Well, let's take a look inside.
Okay, perfect. Lighting system here. These are the engine controls here for the power. With these two throttles full forward, we're producing over 8,200 pounds of thrust.
And the best part about that is when we had Brian and John up in the cockpit and we were doing rolls and loops and stalls, and I'm only kidding. We weren't doing things like that. It would be hilarious not to see.
Hilarious.
But I'm sure they would be like, no, you go in and experience all of that. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we'll go back to the phones from Old River. Riley, how are you today?
Good, how are you?
I'm wonderful. And you are a 6th grader, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. 8 less than 3/4 of a number is 91.
Okay.
Find the number.
So Riley, it's 8 less than 3/4 of a number is 91?
Yeah.
Okay. So I'm going to first ask you, Riley, how would you tackle this problem? What stands out the most to you, first of all?
The 3/4.
The 3/4, okay. What's the next step that you would do?
Do 8 less than that?
Okay. Now, here's my other question. It says, is 91. What does that is 91 mean?
That means something. Okay, so 3/4 minus 8
But what
of a number is 91.
yeah, what does is 91 mean? Does that mean equals 91?
Yes.
Yeah, that's the first thing we need to do because that's the easiest thing to read. Is 91, that tells us right there, it equals 91. So let's go ahead, and that's the first thing we're going to do is equals 91. Then let's look back at it, and let's really look at these words. It says 8 is less than 3/4. Well, the key word is less than. When we see that, it's really saying we're taking a number and we're subtracting 8 from that number, okay? So the 8 less than, that means we want to minus 8. So now what I have written, Riley, is that I have a minus 8 equals 91. Now you said at first the 3/4 of a number. Yeah, that is really important because it's saying 3/4 of an unknown number. So we could take that, Riley, and write it as 3/4 or 3/4 times our unknown number. Because when it's the word of, Riley, that word of means multiplication. So it's saying 3/4 times a number, okay? So what I have written out, Riley, is 3/4 x minus 8 equals 91. So we could take this word problem and I could put it into an equation, okay?
Okay.
So now what we want to do, Riley, is I want to work backwards to solve for x. So let's get rid of the 8 first. Because it says minus 8, Riley, what's the opposite of minusing 8?
Adding it.
Very good. We're going to add 8 to both sides. So now I'm going to bring down my 3/4 x equals, And 91 plus 8 is what, Riley?
99.
99, there you go. So we have 3/4 times x. And Riley, what's the opposite or the inverse of multiplication?
Division.
Division. So we're really saying 3/4, we want to get rid of the 3/4. So we're going to divide it by both sides, right? And we know, Riley, when we divide 3/4 divided by 3/4, Riley, what happens to our division sign when we're dividing by fractions? What does that change to?
A decimal?
Oh, no, our division sign actually changes to a multiplication sign, doesn't it?
Okay.
And then 3/4, what do we do to the 3/4? Do we do the reciprocal of 3/4?
Yes.
Which is 4/3, right? We do this, Riley, because I want to get rid of the 3/4. I want it to equal 1. So that's why we're dividing. So I'm going to take this 4/3, and I'm actually going to multiply that by the other side. For 99 times 4/3. Because we did our 3/4 divided by 3/4, so we got rid of that. And we now have our x variable by itself. So Riley, now we're going to go 99 times 4/3, okay? Riley, how do I write 99 as a fraction?
99/1.
Good job. All right, and then I'm going to do some cross simplifying because I know that 3 goes into 99. 3, Riley, goes into 99 how many times?
33.
Very good. There you go. So now I'm simply left with 33 times 4, okay? So we're going to come over here. I'm going to get rid of that. And we're going to go 33 times 4, which is going to get us 132. And there we go, Riley. Again, let's review real quick. Our problem was 8 less than 3/4 of a number is 91. Remember, Riley, look for your keywords. Is means an equal sign. Less than means we're subtracting, and of means we're multiplying. And we could put this into an equation and then work backwards to find out what our missing number is. And again, our solution is x equals 132. And there you go, Riley.
Thank you.
You're welcome.
Nicely done. Riley's also got herself entered into that drawing for the 4 tickets to go see the Bakersfield Condors. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the school year. Reason we bring that up, today the 8th, tomorrow the 9th, and then next week, the 15th and 16th, the final days for live programming for Do the Math this year. So if you're going to need some free help and you want to utilize the service, you've got a couple more days to do that. Right now, we're going to head back out live to Casa Loma Elementary School and Devin.
Thanks a lot, Mike. We're back here at Casa Loma with Dara and Malaysia. Ladies, thank you for joining us here on Do the Math. And you're going to help us out with division. So, you know, when you have to remember a division fact, we can start to feel the sweats, right? Oh, it's a division fact. Got to remember it. Like they're tough to remember, right? So we're talking a little bit about what division really is. And so when we talk about division, there's a couple of things we think about. We think of division and multiplication. And when you think about what division and multiplication are to each other, how are they related to each other? They both relate to math facts. And so what we mean by that is there's a relationship, what we call the fact families. So take a look at this problem. This is one that frequently gives students a problem when they try to remember their division facts, right? 32 divided by 8 equals... So there's a lot of things you can do to help you remember this fact if we're stuck with it. The first thing that a lot of students do, that a lot of teachers guide them to, is to remember the relationship between these numbers. So here's what we mean by that. We can think of this problem as belonging to the same fact family as this problem. 32 divided by something equals 8, right? Well, now we know that that's going to be 4, but let's talk a little bit about why that's 4. Because if we think about multiplication, something times 8 is going to equal 32. That's what we're really saying with 32 divided by 8. So what times 8 equals 32? If we think about what times 8 equals 32, we don't have to just jump to times facts. We can use repeated addition, which is what multiplication is. So let's think about 8 and figure out how many times we add 8 to get to 32. So let's add and count by 8s. 8 plus 8, 16. 16 plus 8, 24. 24 plus 8, 32. So there are, how many times did we end up adding 8? Well, we're forgetting one very important one, from 0. We got to start with 0 always. How many times did we end up adding 8 until we got to 32? Yeah, let's count those, right? 1, 2, 3, 4. So 8 times what equals 32? 4. 4, absolutely. Now, if that works, that means that 8 times 4 is going to be 32 because those switch in multiplication, right? That doesn't quite work in division, though. Could you switch the numbers around in division and have it be the same thing? No. Unless it's in a certain place, right, towards the end. But I think this is a really interesting concept that kids forget about multiplication and division. It's not just times and divide. Multiplying is repeated addition. So that means that division is repeated subtraction as well. Let's go ahead and try that. If we're doing 32 divided by 8, we start at 32, and we're going to find out how many times we take what away?
8.
How many times we take what away? 8, right? So let's count how many times we take 8 away. 32 minus 8. That gets us to 24. 24 minus 8 is 16. 16 minus 8 is 8. And 8 minus 8 is 0. So how many times did we take 8 away from 32 until we got to 0?
4.
4, right? 1, 2, 3, 4. So 32 divided by 8 equals 4. Now, this works really well with any of those division facts that you have to remember. Repeated subtraction. So let's prove that this works with another division problem that is easier to remember. So we're not arguing about what the division fact is, we're just showing that this works. So let's go to a tried and true division problem. Let's try something like 70 divided by 10. And I want to prove why 70 divided by 10 equals 7. So who wants to try that with repeated subtraction? It's all yours. So Melissa's going to go ahead and start with 70. All right? We're starting with 70. We can go ahead and put 70 up top and figure out how many times we take 10 away from 70. So let's start off with the toughest part of just the first time. We'll take 70 minus that first 10. Let's take our first 10 away from 70. Yeah, so 10. And we subtract that. 70 minus 10. It's going to be 60. Let's take another 10 away. Let's keep doing this until we get down to 0, okay?
Okay.
So we've gotten down to 40, another 10 away. We'll keep doing this. Remember, division is repeated subtraction, just like multiplication is repeated addition, all the way until we reach to 0. So we're at 20, take away another 10. It's always tough when you get to the bottom of that smartboard, you run out of that space, right? So let's go ahead and extend that. 20 minus 10 is 10, and another 10 minus 10 is going to get us to 0. So now, how many times did we take 10 away from 70? Let's count. Ready? 1, 2, 3, 4, 5, 6, 7. 70 divided by 10 is 7. Ladies, back to the camera. Mike, back to you.
All right, doing some great work out there. Right now, we'll go back to the phones. And from Old River, Nicole, how are you today?
Good.
And you're in 6th grade as well, correct?
Yes.
As soon as you're ready, let's hear the math problem you're working on. So you go ahead and read it.
Oh, okay. After traveling 387 miles, Mick noted the odometer on his car read exactly 27,972. This number reads the same backwards as forwards. What is the next such number, and how far will he have to drive to get it to appear on the odometer?
Okay, so on the dashboard, they show how many miles that you go, and this was the same number forwards and backwards, right?
Yes.
So do you know what that's called? Do you know what the number's called that's the same forwards and backwards?
No.
It actually has a name. It's a palindrome. And so we have to find the next one, right? So what's the next biggest number that's the same forwards and backwards? Well, have you tried working on this? We know that the first two numbers have to be same as the last two, right? So if it starts with 27, it has to end with 27. Can there be another 27 number? Because 9 is the biggest number I can put in the middle, isn't it? Right? So it's not going to start with a 2 and a 7, is it? What's it got to start with? You know?
No.
Well, the next biggest number, if it can't be 27, it's got to be 28, doesn't it?
Oh, yeah.
Right? So the next biggest number in miles, right, would be a 28. And if it starts with 28, what's it got to end with?
8-2.
It's got to end with an 8-2, so it's got to be the same forwards as backwards, right?
Yes.
And we want the very next one. So what's the smallest number we can put in the middle there? What's the smallest
1.
digit? Well, we could put a 1, but what's smaller than 1?
0.
How about 0? So if he read that odometer and saw 28082, is it the same forwards and backwards? It is, isn't it? And is there a number between 27972 and 28082 that's also the same forwards and backwards? I don't think so. That's going to be the next one, isn't it? So that looks like that's our number, right? 28082?
Oh, okay.
How many miles from 27972 to 28082? Well, let's subtract them. If you subtract these, what are you going to get?
I'll subtract it right now.
Okay, what do we get? Subtract it right now. What do we get?
Wait, the number is 28082.
82. Mm-hmm. And so we have 28082 minus 27972, right?
Yes, it is 110.
110. So the question was, what's the next number? And that's going to be 28082. And it's how far?
110.
110 miles that he has to travel to get there. How's that? Okay?
Good.
All right, great. Thanks for the call.
Great problem right there. And as always, all of the students that are phoning in this afternoon are eligible to win themselves a 4-pack to go see the Bakersfield Condors. We were just looking at the schedule, and there's a game tonight. So whoever wins tonight, you can't go tonight as far as, I mean, unless you race down here and come and get the tickets. Anyway, there are a few more games this month, and then in April, we've got 4 more games. So hopefully they can take advantage of those and go see some Condors hockey. Right now, we'll go back to the phones. A student from Rosedale. Mason, how are you today?
Good, how are you?
I'm wonderful. Are you in 7th or 8th grade?
7.
All right. As soon as you're ready, let's hear the math problem that you're working on.
All right. How do you find the angle of a rhombus with a side length of 2 units and a width of 1 unit?
Okay, so was it the length, Mason, of 2 units?
Yes, ma'am.
Okay, so the length is 2 units. You do an L. And the width was what?
1 unit.
1 unit. And Mason, read the question again.
How do you find the angle of a rhombus with a side length of 2 units and a width of 1 unit?
Okay, so a rhombus, right? A rhombus is almost like a kicked over square, correct?
Yes, ma'am.
Okay, so we need to find the angles of that. So if we know that a rhombus starts off like a square, okay? It's very similar to a square. And a square has 4 90-degree angles, correct?
Yes, ma'am.
Okay, but if this particular one has a length of 2 units, okay, so our length is 2 units, and then, a rhombus is kicked over. It kind of is slanted, right?
We'll give you about a little over 2 minutes on this.
Okay, so 2 units, and then our width is 1 unit. Then what we're going to have here is we're going to have vertical angles that are congruent, okay? And you know what vertical angles are. They're angles that are across from each other, correct?
Yes, ma'am.
So looking at this, we will probably have 2 obtuse angles and 2 acute angles. And then Mason, for a rhombus, do you know what all 4 angles need to equal?
180 degrees.
Is 180? That's a triangle. Double 100.
90 degrees.
It's actually 360 degrees. Okay, because a rhombus is actually 2 triangles put together. And if a triangle is 180, and if I have 2 triangles, 180 plus 180 is 360. So I know that it has to equal 360 degrees, okay?
Okay.
So again, the question, Mason, is how do you find the angles on a rhombus?
Yes, ma'am.
Okay, but it's not asking you for the exact angle measurement, is it?
Yes, it is.
It is? Okay.
And you've got about a minute.
So
I
can
got
I
about
ask
a
you
minute.
a
Yes,
question?
go ahead.
I have a question. If it's a rhombus, what do the length and the width represent? Because we know in a rhombus all of the
The
sides
sides
are
have
the
to be
same.
same.
So
Yeah,
I'm
so
not
that
quite sure
doesn't make...
what the length and the width are. Does he have
Yeah.
a picture for this?
Yeah,
Really
Mason, did it
curious.
have a picture on this one?
They just have the rhombus like that, set up like that.
It just had the question set up like this?
Mm-hmm.
Okay, because a rhombus, it should be 2 units and 2 units. It's not asking about a parallelogram?
No, ma'am. It's asking about a rhombus.
All right, maybe
Yeah.
what we can do is we can take care of this
Yes,
off air
we
in
will.
just a couple of minutes.
Yes, we will.
So we'll be able to do that with you, Mason. We'll get back with you, and that way we can take a little bit more time and make sure that we address everything correctly. Right now, we'll go out for the final time to Casa Loma Elementary School.
Hey, Mike, thanks a lot. Back here at Casa Loma with a couple of our problem solvers here today. We have Denise, we have Dara. Militia had to check out. Militia, thank you very much for helping us out today. You can see they have wasted no time in donning their complimentary Do the Math t-shirts. They'll wear this around school, get a little bit of promotion for our program, but also showing out that shade of blue. In addition, ladies, I want to award you with your McDonald's gift cards, 1 free Happy Meal for helping us participate here at Do the Math as we head into next week in our final remote, heading into our final episodes of the season. So it's been a tremendous day here at Casa Loma. Looking forward to next week as well, Mike.
Nicely done out there, and as always, we have a whole bunch of students in here. Possibly, well, definitely one of them's going to see the Bakersfield Condor, so let's find out who our winner is today.
Good.
Okay, all right, today is, you got it, Mason at Rosedale Middle School.
All right, there you go. Congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, in outlying areas of Kern County as well as San Luis Obispo County, that toll-free number is 1-866-636-6284. As always, you can email dothemath@kern.org, but remember, try to email on maybe a Monday or a Tuesday so that we can look at the email on Tuesday, Wednesday, and that way we can back to you in appropriate amount of time. And remember, tomorrow and next week, the final days for live programming for this year for Do the Math. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.